Good afternoon, everybody, and welcome to the DBA Fundamentals virtual chapter in the Australian time zone for the October 2015 session. My name's Warwick Rudd, and I'm your host for this lunchtime session. In today's session, which is on SQL Server on Flash, Rethinking Best Practices, we've got Jimmy May. Now, I'll hand over to Jimmy shortly, but first I've just got a few household rules to go through. Now, with the DBA Fundamentals virtual chapter running out of North America, we've got a new sponsor being SQL Sentry. Over October, November, and December, we're going to be running a prize draw where attendees from each of the sessions for each month will go into a draw, and each month there'll be a giveaway from SQL Sentry for a professional edition of Plan Explorer. So later on this month, one lucky attendee from this session, plus also the two sessions that have run in North America, will hopefully walk away with a professional edition of Plan Explorer. Now for next month, we've got Cindy Gross, who will be presenting on Big Data and Hadoop for the SQL Pro. So make sure that you sign up for that session and join us next month. So without further ado, I'll hand over to Jimmy and we can get the session underway.
Hello, everyone, and thanks very much, Warwick, for the lovely introduction. To be clear, what time do I need to wrap up?
We've got until 1:30, so we've got...
Okay, you might have to ping me and give me a 10-minute warning. Okay,
right.
All right. Hello again, everyone. Thanks so much for joining. I have a lot of material to cover, and so let's get rolling.
Sorry, yeah. Jimmy, do you just want to accept and show your screen?
Accept and show, you betcha. Do you see it now?
There we go.
Okay. Do you see just the one screen with the splash of the first slide of the deck?
So we're seeing your your start screen.
Great. Okay, I'm rolling. All right. Well, here we are. SQL Server on Flash, rethinking best practices, and lots of fun stuff to talk about. Okay, legalese, yada, yada. I am not going to go through this, guys. My new employer wants me to at least show it to you guys. Hey, Flash is the game changer for virtually every app for which it's used. And that's local Flash, like a lot of the stuff that my present employer, SanDisk, sells, or for tiered storage or all Flash arrays. I know some of you know and admire Argenis Fernandez. He's a good buddy of ours. And he works for Pure Storage, as many of you probably know. Anyway, whatever the form of Flash, it's changing the way that we think about performance, SQL Server performance specifically. And I'm going to give you a brief survey of history and some high-level, mostly vendor-agnostic review of options for implementing Flash in the enterprise. A little bit about me. I have had some really exciting opportunities in my career. I used to work at SQL Cat, and now I work for SanDisk. It's amazing. If you were in person, I would ask you, hey, who's heard of Fusion IO? The vast majority of you would raise your hands. Hey, who knows that SanDisk acquired Fusion IO and that SanDisk has its own robust enterprise storage division? Most of the hands would go down. However, that's the case. Fusion IO is now owned by SanDisk. Yes, the same people who manufacture the memory cards. They have a really neat line of enterprise storage options. Well, we may get to some of those. Okay. Oh, yeah, this is where I work. I work for a division of Fusion IO called the Data Propulsion Lab. With a name like that, who couldn't be excited about going to work every day? And this is where I get to flip the faster bit. This has been a meme in my career for quite some time. I had a blog when I worked at Microsoft. Worked there for nearly 9 years, left recently. And one of my readers actually asked me, hey, Jimmy, I added this to my startup options, and now my server won't start. Dude, It's an enterprise-only feature, I told him. Just kidding, just kidding. It's a metaphor. I got him straightened out. All right, a lot of really smart people have helped me with this deck. It's been a work in progress since I first presented it earlier this year in March at SQL Bits, and reached out to the community and have had lots of great input. For those of you who look at the hard copy version of this deck, it's actually pretty large. It's over 100 slides. No, we are not going to go through 100 slides tonight. However, it's got some really cool content, I think. If you go through it, I invite you to left-click in the navigation pane, the slide view, select Collapse All, and you will see those 109 or whatever, how many slides collapse into sort of a table of contents, as you see on the right side of the screen. And that may help you navigate more quickly to the section that you want. Sections are a really cool feature in PowerPoint that a lot of people don't use, but this is not the right context for that discussion, so I'm going to move on. Another bit of preamble. I am working with David Klee, Microsoft MVP, Argenis, and myself at a pre-con at PASS for those of you who may be attending. There's the link. You can easily find us. And also SanDisk. I have 3 sessions at PASS. My colleague has 1. And we have a really exciting booth at SanDisk where we will be giving away lots of neat prizes, 1 terabyte disks for the individual sessions. Yes, come to the pre-con. Come to any of my sessions, my colleague's Brian Walters' session, and you will have opportunities to win a 1 terabyte laptop flash drive from SanDisk. Also visit SanDisk Theater. We have a really cool booth with demos, and I said this would be mostly vendor agnostic, but this is pretty cool. We have several 10 to 15 minute sessions per day, entertaining and opportunities to win prizes. With that, let's get rolling on the presentation itself. We're going to talk about a variety of topics. I'm going to touch on the most important ones for sure, and I'd love to have time. Not only will we talk about, hopefully, data warehouse fast-track reference architectures for BI, filled with Flash, of course. Hopefully, we'll have time to talk about consolidation and how it's just an amazing thing. People think Flash is expensive. That's a myth. But consolidating on Flash can actually save you money in terms of SQL Server licensing. Customers save hundreds of thousands or millions in licensing costs alone. Lastly, my colleague and I, Ryan, have done some really cool work with SQL 2016, and wait till I show you the performance enhancements that the program group has introduced into Always On, and how that works well with Flash. Okay, this is a little bit of marketeering, and I'm going to go past it very, very quickly, but marketeering or not, this stuff is true. When you remove the bottleneck, the I/O bottleneck from your infrastructure, you do get more business done. Customers are happier, costs go down, and you're better able to meet your SLAs. True, 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 marketeering or not. I was talking about doing this presentation recently, and poor SQL Bob said, we don't have any Flash where I work. Poor guy. Don't be this guy. If you don't have Flash where you work now, find ways to get Flash incorporated into your infrastructure. Guys, 15K enterprise class disks, quote unquote, that's a 15-year-old technology, literally introduced in the year 2000. Spinning media isn't going to get any faster, even though spinning disks are sealed in a near vacuum. When you go much beyond 15K, there are literally sound barrier issues, and things go crazy when those disks spin and hit the sound barrier. So you're not going to see disks any faster than 15K. That's it. They've topped out, and Flash is the future. And by the way, I don't say this just because I work for a Flash company. I work for a Flash company because I am passionate and excited about this stuff, where we really are changing the world. All right. Like I said, we're changing the world. It's a genuine revolution. Here's a little slide I used to when I would evangelize I/O and present on I/O. One of the challenges as a Microsoft consultant that I had when I went from site to site that so many people would just ask for, they didn't know any better, they would just ask for capacity. Hey, can I have a terabyte of capacity? And the Sandman would say, sure, here's your terabyte. That's not the way to ask for storage, whether flash or classic storage. You ask for not just the capacity, which is of course important, but also ask for capacity in terms of throughput, especially for BI apps, or IOPS for transactional OLTP type apps. And you want that capacity and performance provided with a specific latency. This is the SLA you need to get from your SAN administrators. For OLTP data files, you want that latency to be 10 milliseconds or less for volumes from which high performance is expected. For DW, non-interactive kinds of stuff, 30 milliseconds is okay for spinning media. And log files, you need very, very low latencies, 0 to 2 milliseconds, or you're introducing a bottleneck into your application. If you have log files, one of the reasons why you don't want to intermingle log files with transactional apps, log files need sequential I/O, and OLTP type apps, by definition, do random I/O. Intermingle those, and your log file is going to suffer a lot. And that means your SQL Server performance is degraded, and that means your application performance is degraded. So for spinning media, we had to isolate log file from random I/O. Okay, now, having said this, this is something I used to evangelize years ago, and those millisecond I/Os are almost quaint now, because in a lot of flash configurations, we're getting latencies in microseconds. Now, don't be clear here. For enterprise, big enterprise quality apps, big apps, high throughput, and or high IOPS, you're not always going to get, even from flash, IOPS in the microseconds, or latency in the microseconds. But it's possible. It's possible. You literally have to change the scale and perfmon in order to see this for some applications. It's pretty cool. In fact, I've got an example later of a very, very, very high throughput app where the latency was less than a millisecond. So what is an I/O? We measure in terms of latency, and this is no question about it in my mind. This is the single most important counter in when measuring I/O. This is the thing that matters. You need, if you can drill down further and look at other things such as IOPS and or throughput, but it's latency that matters. This is what your application is waiting on. This is how to determine whether your disks are performing to as advertised. And in addition to latency, IOPS, and throughput, of course, there's capacity. Hey, and to be clear here, these aren't the only important I/O metrics, but they're by far the most important. In addition, especially for BI apps, we want to look at size per transfer. And now that we've come full circle in terms of used to looking at single spindles, now we're looking at single devices for some of our I/O stuff. Instead of single spindles back 15 years ago, when we would physically isolate indexes from data files, for example, and queue length was important. Now we have single PCIe devices, or a very limited number of SAS or SATA flash devices, where queue length is once again important. So latency, IOPS, throughput, capacity, transfer size, and sometimes queue depth are the important counters for I/O. And what's the impact? Microseconds, milliseconds count. For years now, Google, Amazon, other customers listed here, as well as some of our own customers, have striven to mitigate latency, mitigate response time, minimize response time. Failure to do so costs business. We've all been in front of websites where we get the hurry up and wait icon, spinning, 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 spinning. Sometimes we've got to sit there and watch it. Many times we just abandon such sites, those pages, right? So response time is very, very important, and Flash can help. A couple quotes that I love: performance is paramount, asking users to wait is like asking them to leave. Another one: if it's fast and ugly, if your app is fast and ugly, people will use it and they will curse you. But if it's slow, they just won't use it. And app performance isn't something you do once. It's a way of life. It's a practice. It's a pattern. Okay, so what's next? Hey, Warwick, it's time for the quiz. Just about. I've got to hit the slide. I hit a slide here. Just a second, please.
Jimmy, let me know when you want that quiz put out.
All right. Yep. Inadvertently hit a slide. Sorry about that. Ever-evolving deck, I suggested. Okay. The quiz is imminent. Just a second. We have a picture of a spinning media here. Everybody knows and loves this one. And most of you by now have seen a PCIe card, even if you haven't had the pleasure of touching and working with them. There's the picture of one. So here's the quiz, and there it is at the bottom. Warwick, I would like to get some answers, and for 10 or 15 seconds, I would love to see the range of responses. How many conventional 15K enterprise class hard drives to match the IOPS of a single PCIe flash device?
Okay.
Are we getting responses there?
We are, and close. Okay, so Jimmy, back to yours. We have 40% have said 1,000, 28% have said 100, 24% have said more than 1,000, and 8% have said 10.
Okay, that's an interesting range. All right, well let's look. Getting the mouse to work. There we go. There's 2. No, that's not 2. 3, 4, 5, 10. Nope. 20. Nope. 40. Nope. 100. Nope. 200. Nope. 400. Nope. 800. 1,200. 1,200. We're at 1,200. We haven't hit the threshold yet. 1,600. Turns out to be more than 1,900. More than 1,900 classic spinning disks to match the IOPS of a single PCIe device. Now look, guys, let me be clear about something. The IOs that we're measuring here aren't the IO that SQL Server would generally produce. Spinning media metrics that are publicly available are published in terms generally of 4 KB IOPS, and the SQL Server doesn't generate 4 KB IOPS typically, but that's a number that was easy to see publicly, and so I took an enterprise class spinning device, took those. Took the metrics provided by the manufacturer and did some testing on a PCIe device. And it turned out that we got the same IOPS as it would have required 1,900 classic disks to provide. So if we're looking at SQL Server size IOPS, then it's not going to be 1,900. I'm not going to kid you there. But the point is, it's dozens to hundreds and sometimes over 1,000, depending on the size of the IOP, depending on the size of the workload. PCIe flash or standard form factor flash, far, 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 far more performant than spinning media. And let's look a little more closely at some of the numbers. As I just talked about, for a random 4K reads, 600 gig 15K hard drive, will provide about 181 IOPS, according to the manufacturer. One of our standard PCIe devices, 345,000. 345,000 IOPS. Okay, again, 19,000 disks required, 1,900 disks required to match that. For random reads, there is the calculation for that. And look at the physical capacity required. Instead of one PCIe disk or device you can hold in your hand, 1,900 enterprise disks piled up one on top of another, 15.8 stories, almost 16 stories high. Seriously, guys, this is even if we're looking at SQL Server types of IOs, 8 KB, 64 KB, the number is going to be many tens of feet, okay, to match what one PCIe device could do. How about weight? Over a ton of those disks. And here are the sources. And let me talk about this just a little bit. We have example, this is obviously a done to prove a point. We do have literally dozens of examples of TPCH type world records, fast track certifications, consolidation exercises, a whole spectrum of different data points where a server full of flash or a DAS full of flash takes the place of one or more full-sized SANs in terms of performance, I/O, throughput, etc. That isn't contrived. I'm talking about real-life examples, and we hope to get to some of those examples a little bit later on. Again, be clear, this is kind of contrived, but it's there to prove a point. The numbers are real, and we'll talk more about that in a few moments. Relative performance. Here are some, just one look at this. Spinning media, another versus two different kind of flash devices. One of them happens to be ours. It doesn't matter which one is which. One of them is from a competitor. And in terms of IOPS, you get 180 times to more than 1,000 times the number of IOPS for these particular devices versus spinning media. In terms of throughput speed, flash, depending on the device, was 30 to 70 times faster. Pretty impressive, I think. So now, folks, after that brief introduction into some of a little bit about latency, a little bit about IOPS, a little bit about the outstanding comparisons between standard storage and flash, let's talk about best practices. And this is something, the other stuff was fun and interesting. This is something about which I'm far more passionate. So here we go. This is very important. Yes, flash can seem like a magic bullet, and sometimes it is. It can mask many performance, config, and design challenges. And the reality is, sometimes throwing money at a problem is an expedient answer. However, best practices remain fundamental, and there is. This is something I've evangelized for over a decade. There is no substitute for engineering discipline in terms of application and database design. Some of you may be familiar with John Wooden from Indiana, UCLA coach, famous. Great quote by him. If you don't have time to do it right, when will you have time to do it over? So folks, as you go by, if you take nothing away from this presentation, this is the take home. This is what I would like for you to take home. It has nothing to do with flash specifically, but it has everything to do with building things right. Okay, some workload characteristics and pain points. Transactional workload, small block, high IOPS, low throughput, and generally low latency required. Versus data warehouse, large block, sequential I/O, not random. Far fewer IOPS typically, much higher throughput required, and much more forgiving in terms of latency. So how do we address those pain points classically? Well, we over-provisioned shared storage. What does that mean? We short-stroked our disks. For those applications from which high performance was required, we did not fill up our disks. We filled our disks up to 20, 30%, no more than 50, in order to get high I/O. And the problem with leveraging disks as you fill them up, latency goes up, IOPS go down. The bottleneck is not the storage, not the CPU where it belongs, and it can be expensive. People think, oh, flash is expensive. It's cheaper than ever. But even as recently as 2 or 3 years ago, as Flash wasn't that expensive compared to things such as the number of disks required, licensing costs, infrastructure costs to connect the storage to the server. It wasn't cheap, folks. So what does Flash do? Flash liberation, who wrote that? Solid state, SSD, Flash minimizes seek time. Very ultra low latency, up down to as few as microseconds, and it works for small and large block size. High throughput, 29 gigs per second. At low latency, we have a solution I'll show you later. Happens to be SOFS, scale out file server architecture. That we 96 disks produced over 40 gigabytes per second of sustained latency. Just 96 SSD disks, 40 gigabytes per second of sustained throughput at low latency. So best practices. Some of these we all know and love. Nothing special here. Trace flag 1117, trace flag 1118. Long has been a best practice for tempdb configuration. Multiple equal-sized tempdb data files, long a best practice to minimize latch contention, right? And by the way, these are so fundamental that they're actually baked into 2016. You can't turn off 1117 in 2016. You can't turn off 1118. It's just there. But it's baked right into the product. And when you install 2016, you are prompted by default. There's a new tab in one of the dialogues prompting you for the number of database files. And the installation process actually looks at the number of cores you have and provides a suggestion. It's pretty cool stuff. And if few of us are deploying 2016 now, but between now and the time you do adopt it, consider making these mandatory components for all your SQL Server deployments. Also, again, no secrets here. Long been a best practice for Enterprise Edition at least, to enable to add the SQL Server service account, to user rights assignment, allow it to perform volume maintenance tasks, to enable IFI, and to enable lock pages in memory to prevent paging. Don't look now, paging is death for SQL Server. We were doing some work with some Hyper-V recently and had hired a contractor to do the work. And I was brand new at the job, had just been hired a couple weeks before, and I was thrown into the mix. Fix the performance problem, Jimmy. What's going on here? And fortunately, it was such low-hanging fruit. I looked at the perfmon metrics and saw paging. What? The configuration had failed to set up lock pages in memory. It was just as simple as that. Boom. We did lock pages in memory, and we were off to the races. So again, these are fundamental. Nothing specific to Flash here. But they're important for high-performance apps, whether you're using spinning media or whether you're using Flash. Some more, mitigating memory latch contention. Not just tempdb, as we just discussed, but for user DBs, multiple equally sized data files per data file group. And it turns out 8 files is the sweet spot for most implementations. So as I have come to the new job and I've looked at some of our benchmarking databases, for those designed to test OLTP, I am reconfiguring all of our benchmark databases and configuring them with multiple data files. And this is interesting. I mentioned a little while ago how log files require sequential I/O, and they also require very, very low latency for high performance. And you just can't intermingle that sequential I/O with random workloads. It's death for SQL Server performance. The thing about Flash is there is no concept of physical sequential I/O. I'll get to a little bit more on that later. And for many applications, one Flash device can support not only the data files, but also the log files. Now, this depends. Remember that I/O mantra I shared earlier, where with the given latency required for data files, whether it's transactional or data warehouse, and specifically had the last bullet, the last line, citing the latency required for log files. Very easy to determine whether or not you're just simply look at perfmon. Simply look at perfmon, or do a derivation from output of virtual file stats to determine whether the the log file that you may have on your flash device intermingled with data files is performant enough. If you're not saturating the performance capabilities of a flash card or drive, it is possible, again, you've got to check, to put a log file in a data user database log file and intermingle it with user database data files if you're getting the performance that high performance demands. So if you're not saturating the card or not saturating the SSD devices, whether they're SATA, SAS, or PCIe, it may be possible to intermingle workloads. Oh, now that's pretty exciting, potentially very liberating in terms of data management. Think about that in terms of not just discrete databases and log files, but maybe intermingling virtual machine workloads. Oh, opens up whole new opportunities for us in terms of ease of management. Okay. I talked about consider segregating log files if performance demands it. Here's a no-brainer option for just about every workload I've ever examined, and with few exceptions I've ever heard of. Optimize for ad hoc workloads is a no-brainer for almost every implementation. May not help at all, could help a little bit, could help a lot. A little bit of testing required. This is a SQL Server configuration option that's relatively new, and consider just flipping that bit and checking out your performance. Test, of course, always. I'm not suggesting you go to, you log in right now to your production servers and flip this configuration option this second. You do want to do some due diligence, of course. Power options, oh, this is very important. And again, spinning media or flash, nothing new here. For Windows, enable high performance. This is within the Windows UI control panel. In the BIOS, you want to enable hyperthreading. Hyperthreading used to have a bad name. I'm sure some of you out there were around when the original implementation of hyperthreading was released. Oh, what a nightmare that was for SQL Server. It earned a deserved bad reputation. So bad, in fact, that when Intel re-architected a new kind of hyperthreading and rebranded using that same term, I was shocked that they did use the same term. But the new improved hyperthreading is just great for every SQL Server workload on which I have seen. And another enabler for high performance, high or increased cooling. We have some friends that had a very, very, very popular survey engine that bought some PCIe cards, and they weren't getting the performance they needed until they went into the BIOS and flipped the bit corresponding to push those fans up. In some BIOSes, this is not a separate setting, but what is always there is the following. C states, to be green by default, all servers now provide an option to power down the server CPUs when it's perceived not to be in use. Folks, let me tell you, Adam Mechanic, some of you know Adam, has a beautiful presentation where he throws what appears to be a very high, it is a high workload. It seems to be constant, what appears to be a very constant, high throughput workload, very demanding on a server, and he, in real time, monitors the behavior of the CPU when these settings are at their default state. That CPU, right before your very eyes, when being subjected to this apparently constant workload, is going up and down, up and down, up and down, up and down. He flipped this bit off in the BIOS, rebooted, and showed us the much, 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 much higher throughput. Another example, when I was still at MSIT, after I left the CAT team, I went to MSIT for a while, and we did some very interesting work with some virtualizing some big SAP workloads. It wasn't until they flipped that bit that they got the performance that they needed. So, on your servers from which high performance is expected, spinning media or flash, consider looking at these power options. Okay, storage devices. Logical volume configuration, disk partition alignment remains important. Format your drives for SQL Server data files and log files to 64 KB. Here's something interesting. Any of you out there updated ever updated the firmware for a spinning drive? I haven't. Some people do. I just have not. Haven't needed to. It turns out that for PCIe flash and eSATA, or SATA and SSD flash, keeping the drivers up to date, like all of your other devices, turns out to be very important. And this is far more important for flash devices than for conventional spinning media. And there may be some vendor-specific recommendations. Default power settings may not be optimal. For old-fashioned Fusion I/O cards, it was very, very important to explicitly set the power for the card itself. And it's still important in some implementations today. Also, you want to consider low-level formatting at 4 KB, not the 512 bytes that we have used for the past 20 years. Be careful intermingling 4 KB allocations with or low-level formatting with 512 byte formatting, especially if you're using implementations like Always On. You don't want to have your new server at 4 KB and format, and your old server that you're doing high availability with at a 512 byte format. So keep your storage that for example, for Always On implementations, keep them in sync. And just a summary of power. I've mentioned power in 3 different contexts: the BIOS, Windows, and possibly PCIe configuration. All 3 need to be examined. And you should consider this a default, as opposed to some of the things that we talk about. Test, test, test. These things you should consider them as the default options. No-brainers. And failure to do so, some of you out there with Flash may be losing performance because you haven't enabled these options, and you just don't even know it. Bandwidth. If you have a server, the contemporary servers can easily hold 24 SSD drives now, and with an extra controller card in there, you can support up to 12 gigabytes per second. That's pretty cool. That's pretty cool. And by the way, those 24 disks, that's up to 96 terabytes of storage in a single 2U commodity server, folks. That's extraordinary. That's almost 100 terabytes. And but if you're not careful, you might run into some thermal issues. So there's the fan issue again, and also make sure that your rack doesn't get too hot. Just something to be aware of. When you're putting PCIe drives into PCIe slots, make sure that the slots are the right version, make sure that they're the right bus speed, and also you might want to check the bus power to make sure that that slot can support the power your PCIe device demands. And so now we've gotten some configuration things behind us, and let's talk about backup. Whether flash or spinning media, here are some things that you can consider. You need to develop your backup strategy compliant with your business requirements. And as Kimberly Tripp has said for years, you don't have a backup until it's been restored and validated. Do not rely on a reported success in your MSDB history. You need to restore those darn databases and make sure that they work. Fragmentation. I mentioned a bit ago that there is no logical concept. This baked my noodle for a while. There is no concept of physical sequential storage in Flash. Lots of things going on under the covers. I hit a slide, speaking of baking one's noodle, I hit a slide related to the red pill and blue pill in terms of index or disk internals. It was bad enough for spinning media. It's even more complicated for Flash. Lots of things go on under the covers in Flash. Data gets moved around to create larger blocks of space, for example. And but SQL Server itself relies on logically contiguous pages. So especially for your BI apps, you need to do your defrags. Formerly, that was a challenge. People said, "Oh, Flash will wear out." Contemporary enterprise class Flash will not wear out. I say that almost unequivocally. Yes, of course, there are limitations. Yes, of course, there are exceptions. But their guarantees are extraordinary. And they're very, very, very likely to outlast any spinning media disk out there. Sort in tempdb. Build your indexes, especially for your always-on implementations. And again, this is largely a no-brainer, whether you're using Flash or spinning media. But if you're using, for example, you have a PCIe card on which your tempdb resides, and you're still using conventional media for your data files, it's a no-brainer to do your index maintenance using sort in tempdb. And if you're using always on, that's a lot less log traffic to throw across the wire, folks. Okay, I'm looking at the time, and I've got about 15 minutes left. So I'm just going to show you some backup and restore options that we use. These are things I learned from Thomas Kaiser when he and I were at SQL Cat together. And if you haven't leveraged these, you can dramatically decrease your backup and restore times. Use sp-configure and make these things your default. Backup checksum default, backup compression default. Enable those, folks. Here is a prototypical T-SQL backup syntax. By the way, this deck will, of course, be available. You're welcome to contact me. I'm easy to find on Twitter and Facebook and other mechanisms. I'll be at PASS. If you have any questions, please ping me electronically or in person. And these are the things that I use reflexively now. With the possible exception of maybe not using stats=1. I don't always need to see every percentage of completion. But everything else I use. And backup times are dramatically improved. There's a prototypical restore. I won't belabor that. And for those of you who don't know, our friend Nick Kane at SirSQL on Twitter has a tool. You can test these configuration options in your own environment and determine what works best for you. That's a relatively straightforward POSH implementation that he lets you do these tests with, or that he enables you to do automagically. Pretty cool stuff. Data compression, long a best practice for SQL Server data. Typically a relatively small CPU cost, and I have never seen an implementation where compression didn't help. There are the usual caveats about, oh, CPU utilization. Folks, it's a no-brainer. At MSIT, this was our default. It just was our default, and we saved petabytes of storage space by enabling compression. And note some Flash vendors provide compression or dedupe by default. That may impact its value in your environment. And in the interest of time, I'm going to talk about this very, very quickly. Let's look at the three bracketed bars. On the far left, we have a table with just customary indexing, but no compression. Next to that, we have standard data compression. We have almost cut the storage in half. Those of you out there who have experimented with Columnstore, anybody out there using warehouses and not using Columnstore, boy, you have. The world of Flash is exciting. The world of Columnstore is very exciting. Columnstore is the default index of choice for SQL Server. And look at those compression ratios. By a factor of 10 over uncompressed data. By a factor of 5 over standard data compression. So let's talk a little bit about Columnstore. I have a whole full-blown 3-hour presentation on Columnstore. I would love to talk more about it. It isn't the focus of this presentation, not even close. So what are we looking at here? This isn't Flash versus spinning media. This is Flash on Flash. Each of those pairs of bars represents an I/O throughput workload. One using row store, the exact same workload against row store, the exact same workload against column store. So what are we looking at? The red bars represent row store. Note that in these hour-long tests, so each pair of bars corresponds to a specific server. So those two, the red and blue bar on the far left, labeled 2014-003, that's just a server configuration, a server filled with Flash. On the right, 2014-032, that's another server filled with Flash. So those each pair of bars represents an individual server. The red bars represent the row store. The blue bar represents Columnstore. Again, both of them on Flash. So focus on the red and blue columns. Don't worry about the black line for now. It corresponds to the secondary access and represents the certified DB size. But each pair of columns represents results from a fast-track warehouse reference architecture. And for each pair, we're comparing performance metrics from the same system. Again, RowStore red, Columnstore blue. The takeaway from the first chart here that you see is that the red column is doing a lot more physical work. It's generating a lot more megabytes per second throughout the hour of the test duration. Typically about 3 times as much physical I/O per test. Yet, check out the chart on the right, which is appearing in a second. Notice here the size of the bars are inverted. The red bars are shorter, the blue bars are higher. What is this telling us? What this is telling us is that even though the Columnstore implementation wasn't doing nearly as much work as the RowStore implementation, it produced much more output. Look at the labels of those graphs. I/O throughput on the left, query throughput on the right. So Columnstore isn't doing nearly as much work as we see on the left side, the left chart, but on the right we can see even though Columnstore wasn't doing as much work, it produced much more output because it's that much more efficient. So the takeaway from this slide is Flash, Columnstore on Flash rocks. Flash works great for RowStore. You apply Columnstore indexing to a Flash implementation, and you're off to the races. You have far more efficient SQL Server implementations. I would love to talk more about this, but this isn't the focus of this presentation. Okay. Columnstore indexes, let me be clear about something. My colleague and I agree. It was vastly undersold, but it is by far the best thing to come out of SQL Server 2014. Clustered Columnstore, the best thing to come out of SQL Server 2014. And no one knows this. Microsoft explicitly recommends that Columnstore be the default choice for warehouse tables. And folks, leverage table partitioning in your warehouses if you're not doing so already. We have some options here that I would love. First of all, we don't have a lot of time. And secondly, we don't have a lot of guidance for you yet, but we are actively exploring these very exciting options. I'm going to go past myths for now because I want to get into oh boy, what I want to talk to you about cost. Briefly, let me just say, Flash is cheaper than spinning media, not only in terms of raw cost today, but it's long been cheaper in terms of total cost of acquisition. In other words, the licensing you have to pay for SANs, the network infrastructure, the fiber, the switches, etc. Flash has for two years now been less expensive than conventional storage. Today, as of now, Flash is less expensive than spinning media from the day you buy it. It's remarkable stuff. Do some pricing. Check your OEMs. Don't be misled by some of your SAN salespeople. All right, do your due diligence and find out for yourself. I want to talk about some user cases, and I'm going to go straight into. Boy, do I want to go into this in more detail. Windows scale-out file server, some exotic new thing that Microsoft is trying to evangelize. Folks, it isn't just another acronym. This stuff rocks. Okay, I mentioned this earlier. 4 JBODs with 96 disks total, network switches, and 2 clients. I'm sorry, 2 servers to act as controllers. And in this particular example, we have 4 client machines stacked on top. 1 a 4U, 2 3U. Check that out, folks. Where are the performance numbers? I know I don't have performance numbers here because I'm not supposed to document them in writing, and I know I'm being recorded. But I will say again what I said earlier. This configuration, less than $500,000 total, including SQL Server and Windows licenses, produces sustained 40 gigabytes per second. Come to us, come to our booth and talk to us about it at PASS. We'll tell you more. Oh, and by the way, this is dual parity. don't forget, and with very low latency, less than a millisecond latency. Okay, so dual parity, full redundancy, pull out any cable, boom, you're still off to the races. Pretty cool stuff. Imagine your environment filled with VMs on top of this flash, generating 10 gigabytes per second per client, 40 gigabytes sustained, amalgamated. 40 gigabytes per second sustained, day in, day out. Folks, there's nothing out there like it. And this is not an exotic configuration. It's we built it using Windows guidance, published guidance. Okay, I want to talk about the new improved always on before I wrap this up and hand it back over to Warwick. Basically, I have a load driver. I'm using Hekaton. The fact I'm using Hekaton, I had to use Hekaton. I couldn't find a combination of tools that would give me the throughput I needed to test this configuration. But Hekaton itself is beside the point. The point is that the point is to show you the always-on throughput. So the bottom two servers on the right correspond to the primary and the replica. I'm going to look at these bullets to see if there's anything interesting. I'm good here. This is the hardware configuration. This is the OS and SQL Server configuration. The interesting thing here is I was running out of max worker threads. I was getting thread pull weights. So I had to up the default max worker threads, which is not something I have to do very often, in order to maximize throughput. So let's see what happens. Let's look what happens in always on. Briefly, summary, we leveraged 4 times more CPU. We generated 5 times more transactions, and we were able to leverage the flash more. And this is a function of the improvements that the SQL Server Program Group has introduced into SQL Server 2016 Always On. 3 times more throughput, 4 times the IOPS at very, very, very low latency. So let's look at this. What are we looking at? 2 things. There were 2 bottlenecks to SQL Server 2014 Always On. There was the transport, and there was the redo thread. Well, so far, the program group in CTP2 have fixed the transport. They're going to work on the redo. They haven't done it yet. I'll show you the chart in a moment. Okay, so here is on the left, so the red is SQL Server 2014, and on the right, SQL Server 2014, or 2016, I apologize. Red is 2014, gray is 2016. We were able to leverage 4 times more CPU, 5 times more transactions, and we were able to get 4 times the log traffic across the wire. This is the function, folks, of the fix that the program group has done for Always On. Very, very cool. This is enterprise class. Before we were bottlenecked at about 40 megabytes per second. Now with the fix, we can get almost half of a gigabyte per second across the wire. The redo thread hasn't been enhanced yet. The program group is very optimistic they're going to be able to do so. So folks, this is, we were limited with what we could do with Always On in 2014. There were many implementations that we just couldn't support because of the transport bottleneck built into SQL Server. I don't care how much flash you had. I don't care how fast your CPUs were. That's being remedied, and that's very exciting. So while we're at it, let's look at the flash. We got 3 times the IOPS because of the fix that the program group has given us. We got over 4 times the throughput. And even with that much better performance, we were still at only 1 millisecond of latency. Imagine that kind of workload in your environment and only having to suffer 1 millisecond of latency. That's pretty cool, folks. That's very, very cool. Okay, with that, I know I had to go pretty quickly here to get through some of the important things. I do want to show you very quickly what I think was a pretty cool performance pattern. This is a symphony, a correlation of various aspects of the infrastructure as I was doing this work. Just a beautiful orchestration of various components rising and falling together. And with that, we're going to close with one more thing. With the relative inexpensiveness of Flash today, imagine putting Flash in your developer environments, not giving them the slow, hand-me-down red-headed stepchild storage. Imagine putting your developers on a flash environment. Imagine how much more work, imagine how much more innovative, imagine how much more creative they might be if they've got a environment in which I/O isn't the bottleneck, but it's you moved it to the CPU where it belongs. Okay, with that, I'm going to hand it back over to Warwick. I think it is time now, isn't it, Warwick?
We've got a couple of minutes left, Jimmy. And so to finish that off, we've got a couple of questions that I'll put through to you. Well, the first one's not really a question, it's a bit of information, and it's AWS and Azure measures IOPS as 256 KB IOPS, worth knowing when comparing with physical storage.
Is that question here so I can read it? I see it.
Yep.
Okay.
So that was more of an information bit coming through, obviously with one of your slides.
Thank you.
I
think it would be very useful, frankly, if rather than just comparing the 4 KB, that's easy to measure, to do our own metrics, not against not just spinning media, but also what we can see from the cloud.
Yes.
Thank you. Thanks for pointing that out, folks.
All right. Then our two questions that we've got outstanding. First one is to do with backups. So for a striped backup, do you still see the gain in performance when all striped files are to the same folder?
Oh, yes. Yes, because the bottleneck, unless the bottleneck is the storage. If the storage isn't the bottleneck, but it's the SQL Server internal thread or threads, then you'll see the benefit. All right, so if you're backing up to OneDrive and you're backing up at that the I/O is peaked at 120 gigabytes per second, for example, on a single physical spinning disk, then adding more threads won't help. But if storage isn't the bottleneck, then yeah, multiple threads even to the same folder will help. And of course, strapping your disks will give you more than one spindle. And of course, this works with Flash. Okay, hope that answered the question. Do your testing. If you don't, just look at your throughput. Look, if you're getting during that backup with a single thread, if you're not, take 200 gigabytes per second approximately, times the number of spindles, and if you're not hitting that throughput, then that means you have room for more threads and to enhance your backup speed. I hope that was clear. Please feel free to contact me directly, and we can do an email exchange or some kind of a video exchange, and we'll work through it. Okay, next question.
And our final question for today is, how do we measure performance of a SQL Server residing on a VM infrastructure where VMDK file is residing on a flash drive?
Well, performance has many different parameters. Are you just looking at I/O? You can measure I/O directly from the SQL Server or the SQL Server itself. Maybe I'm missing the question. I apologize if that's the case.
Yeah, it's a bit generic. Now, whether it is looking at the performance of the VM, or how do we test it at the host level? So.
Yeah. Whether you're looking at the VM itself or whether you're looking at Flash, again, this applied to many of the things in my presentation. Whether you're looking at Flash or looking at physical or spinning media storage, for this kind of implementation, you're going to want to look at the host and the VMs specifically. In fact, in the pre-con that I'm doing with Argenis and David Klee, we are going to go over some performance counters. I think that's my section. We're going to decide that for sure tomorrow. So I invite you to join us, or pay for the session, and you can get the recording, or just ping me separately and ask me more details, and I'll do everything I can to get the answer to you. Hope that was helpful.
Okay, so in response to that, Jimmy, it's if we want to find out my VM is faster after putting on Flash. So I guess if you've added PCI Express to the underlying hosts in your virtual cluster, then migrating the VM onto that Flash.
Okay, thank you for the clarification. That's a little bit easier. This is very similar in some ways to the backup question we had. What's your bottleneck today? The goal of Flash, and this is something I wish I could have emphasized more, and I have a Flash for nothing, get your hardware for free section that we didn't even get to on consolidation. I teased you earlier in terms of saving hundreds of thousands or millions of dollars by consolidating because of SQL Server licensing. If your bottleneck isn't the storage today, putting your VMs on Flash is very, very, very likely to enhance performance. If your bottleneck, however, is your application, it's the CPU, you're not allocating enough memory, and that's the bottleneck, then putting on the fastest storage in the world isn't going to help you. So I hope that helps you a little bit. So what I would do is I would measure those critical I/O counters I talked about earlier. I shouldn't say critical, the fundamental I/O counters I showed you earlier. I have a mentee who's a shiny new PFE at Microsoft, and she's doing some baselining for a customer, doing a similar exercise. They're moving to Flash, and they want to know the before and after benefits of doing so. So she's helping them create a one-time baseline, and they're collecting some fundamental metrics, including the ones that I shared with you earlier, and they're going to compare the before and after there. And again, if you need more details, I reiterate, I'm happy to help. Ping me.
Thank you, Jimmy. I think it'll be the last one, but on the last slide, disk throughput was tripled in SQL 2016 compared to 2014. Is that just for always-on availability groups or in general?
Okay. I think this is the slide you're talking about, and this is thank you for asking that question. It gives me an opportunity to clarify. The before and after here, the physical infrastructure was the same. We had the same server, the same storage. The difference here is that the enhancement that the SQL Server Program Group has given us in terms of let's call it, quote, fixing the network transport, allows us to take better advantage of the physical hardware. So this is Flash against Flash. These are the very same disks I ran these experiments on. Just by virtue of the fact that this program group in 2016 has applied a fix, enhanced the performance of always-on network transport, we can leverage our hardware better, including and especially our Flash. Now, are you going to get what do you got here? Almost a terabyte per second. Are you going to be able to sustain that throughput on any kind of spinning media? The answer is no. What is happening here is not only has the SQL Server Program Group done us a great favor, but we now can take advantage of the benefits that Flash offers us. So I hope that's clear. Flash could have done this 3 years ago, but the SQL Server had a bottleneck. That bottleneck is now unplugged, and we're off to the races. That's the point of this slide. And again, if that wasn't clear enough, pay me, and I'll make sure you understand what I'm trying to say. And you'll help me. I'll be able to present this better the next time. So please do.
In addition to that, does that fix depend on the version of Windows as well as SQL 2016?
No, well, this was done on Windows Server 2012 R2, not on Windows 2016. So I don't think 2016 is supported on 2008 or Windows 2008. So the answer is theoretically yes, but you're probably going to be running 2012 anyway, 2012 Windows. So I guess you have to, let me rephrase that. You have to run this on a version that 2016, on the version of Windows that 2016 can live on. Yes. How's that?
Yes. So on a supported version of the operating system for SQL to run on.
That's much better said. Thank you, Warwick.
Okay. So if there's no other questions from any of the attendees, I'd like to say thank you to Jimmy for coming along today and presenting to us on Flash, SQL Server on Flash. Hopefully you all picked up some good little points out of this. And this session was being recorded. The session will be made available on the DBA Fundamentals website in the archive section. I'll get the slide deck from Jimmy so that we can put that up there as well, so that if you want to go back and watch this after the fact, you will be able to. So I look forward to seeing you all next month for Cindy Gross's session on Big Data and Hadoop for the SQL Pro. And thank you for coming along and attending today.
Thanks, folks.
Thank you.